Hey everyone, and welcome to week 3. We're going to continue having a discussion about objects. We're going to be looking at specifically some objects here that are a little bit more advanced, I suppose, in nature, more advanced implementations. So we're going to be looking at references to objects in a little bit more depth than we have previously. We're going to be looking at a cloning method, so understanding that shallow and deep copy when it comes to objects. We're also going to be talking about arrays as objects and more conversation around objects as method parameters. And then in the second half of this video, we're going to be covering objects in objects and how that is going to be, how we're going to be able to do that in a way that is doing deep copies appropriately when necessary and things like that. Okay, so what I can see is that my screen didn't actually update the slides. There we go. Now is it updating the slides? Yes. Okay. So we've mentioned before that every single data type is an object except for doubles, floats, longs, int, shorts, bytes, chars, and booleans. And it's very important that we notice here that none of these have a capital first letter, and that's what makes these the primitive types. So everything else is an object, like strings. I know that arrays don't really have a define type in the same way, but like the square bracket array, those are collections of any data type. So those are going to be objects. And then the things that we're making, and also other things like scanner that we've seen, but or array list. And well, we'll see array list in a couple weeks. We'll see other objects that are pre-supplied in a couple weeks. But there are also objects like math random. You can make a new random, or there's a random class, things like that. Those are all objects. So then whenever we make a variable with one of these types, we're storing the reference to the object, right? Not the value, not the data. We're storing the memory address in the variable so that we can just, whenever we need to access it, just walk over to that memory address and find the object there. Okay, so we're going to talk about cloning objects. So we talked about doing shallow and deep copies of arrays a couple weeks ago now. We talked about how in order to do a proper deep copy, so that we have two separate copies of an array, we had to go through every single element in that array and copy it into a brand new one. We had to make sure we were using the new keyword in that new array so that we were allocating memory for a second array. We couldn't just assign one array to the other variable and call it a day because, as we just said, that doesn't move the values, that only moves the copy of the address. So the data itself is not truly copied. It's really just two references to the same piece of information. So if we want to make a completely new object, just like we did with arrays, since it's an object, we have to actually use the new keyword somewhere. And typically we make a method, and the method is often just called clone. So you would make a clone instance method inside your class. So if we consider our person class from before, we will have our clone method inside there. So what I'm actually going to do, I should have done this before, but I didn't, was I should have copied over our person class from before. So feel free for just to like skip this part for a second if that's what you want to do. But if you are somebody who would like to see me rewrite this code, you can do that too. I'm just going to go and throw this code in our folder here. I need a code folder. Oh, that put the code folder at the wrong level. You know, things are going really well, as we can see right now. And this is going to be week 4, and this is going to be a person.java class. Okay, I'm going to add my constructor back in with a string name and an int age, where I set each of those variables. I will also create my toString in case I need it later. And I'll do it right here with return. I'll just do it in one line. Name, name, and then a space age with a age variable. There, that's just like our basics for right now. And then I'll also make the class where I can do clone object practice. Oh, I definitely need the keyword class in there. And now I can save this, clone object practice.java, and I can do my main method, and then I can make a person, and today we'll do new person Onic. And we can just make sure that this is working before we do anything else by printing out Onic and making sure that it works. Where did my terminal window go? Oh, too tiny. Desktop 1020 code week 4. We will compile all of this code and we will run it. Somebody had mentioned in Piazza that there actually are ways to like set up in Sublime an automatic like build and run, like short like hotkeys for them and stuff. I clearly don't have that set up. That's my personal choice because I do a lot of like switching of languages right now, and so it's just easier for me not to try and have any of that set up, and it wasn't worth it to set it all up for me, but if you wanted to, you definitely could Google how to do that and set it up appropriately. I'm going to move this terminal window to a tab instead of having it here. Just, oh no, oh gosh. Just so that I can make it a little bit easier to just see everything all at once. I thought it'd be easier to have it in the bottom, but it is not easier to have it in the bottom. Not in the way that I thought it would be. Okay, there we go. So that did indeed work. I can run it again just to show Java clone, and we can see that Onic is age 25, and that totally worked. Okay. So if we want to make this clone method, what we're going to do is we're going to add an instance method called clone with a return type person, because we're literally returning an exact duplicate of ourselves. We're not returning our memory address, so we have to use the new keyword, but we are returning an exact copy of ourselves. So what that looks like over here, I have so many windows open, it's insane. Okay, what that looks like over here is making the method public. Oh, I should probably say, for anybody who's zoomed ahead, we're now talking about making the clone method. Is it obvious that I'm just sort of doing this on the fly? Yes, yes it is. Okay, so there's our clone method. And what we're going to do is we're going to make a new person with the exact same information. So we actually return, we can do it with a variable if it'll make it easier. New person equals new person with the exact same, like, this instance method's name, this instance method's age. You don't need the this keywords, but I'm throwing them in just because it might help to see what's going on. There we go. And now we can actually see that we're returning a new person. So when we use this, a reminder that if I make a person Onic2 and it's equal to just regular Onic, and I do Onic equals Onic2, this is going to give me true. Oh, I didn't spell person properly. Why didn't anyone tell me? Just kidding. Obviously, you couldn't have done that. Okay. So when I do this, we can see it gives us true, because all we did here was assign person 1, like Onic to Onic2. So that was just moving the memory address. So this came back as true. Okay. If we want to use our clone method, what we can do is we can instead make Onic2 equal to Onic.clone. And when we do this, the clone method will actually go over here. It will go here. This comes from Onic1. This creates a new person. And then we pass back the person's memory address. This isn't the value. It's where you can go find the memory with this new person in it. That gets stored in Onic2. So now when I try and say, is Onic equal to Onic2, we are going to get false because we actually created a new person in a new memory address separate of the old one. So now this will give us false because the two memory addresses are not the same. Let's just give that a try quickly here. Could this be made bigger? No, I did that right. Okay. Java, right here. So first we got true, then we got false. Because now we have two totally separate people. Using that new keyword is imperative. That means it is incredibly important. It is necessary to get two separate objects that have the same values. Okay, so I also have this written up here with some more information. So here we can see another version of clone where we were basically making a default person, setting the name to the new default person, to the variables within the instance that we're calling it on, and then returning it. Or even if you did this in main, perhaps it would look something more like this, where we would make a new person, we would set the name and the age of the new person, and then pass those back. We'd have to make set name and set age variables, which I didn't do, but here is what it would look like otherwise. Okay, so cloning. We did talk about shallow versus deep copy. We talked about this idea of aliasing, and I just showed it again. Just like arrays, we would only get the change in this scenario where it would affect both. So let's actually just code that up really quickly just to see what that looks like. So let's just add a method here. Oops, public void set name. We'll pass in a name variable and we will change the current name to a different one. So now, right up here, we can see person onic 25, setting onic2 equaling to onic. Here we'll do onic and print out onic's information. And then here we're going to print out onic2's information. Then we're going to change, I better, because I'm going to upload this, I better include like a little bit more information here. Onic object, onic2 object. I can add some spacing there. And then we're going to do onic dot set name to changed onic, and then we'll print these again. Okay. So now we're going to run this. Let me just clear this to move it back up. There we go. And we have onic object and onic object. So those two printed with their name and age. So this part is the toString, and then this is the part I hard-coded for each of them. And then I changed this one's name, right, to change onic, and we can see it also affected onic2, even though in our code over here, I never actually wrote onic2.change, right? So it affected both of them. We can actually see that happen in code. Now let's change their names back. Onic.setName. So we're just going to change it back. Then we're going to do our clone, and then we're going to do this change again. Actually, this is so silly. Let's do this clone, onic2, and then onic, and then let's change onic back and print them out. After clone, oops. After clone. After clone. Ah, there we go. So we do this. And check out after clone, onic went back to normal, onic2 did not. Because we had cloned them, we had separated their information, and then we made changes to onic, and so it didn't affect the onic2 object anymore. So this is just sort of showing what we just described here when we had aliasing versus when we have aliasing here. We saw the change happen, and when we use the new keyword, we use our clone method, we saw that they became two separate entities. Okay. So then when we did our deep copy, our clone, we had our two separate objects. So now a change with one will not affect the other. This isn't an issue when it comes to strings. So we've probably done something like, we'll have actually just done it. This. where we changed one string to another, um, and it was fine, right? It didn't, or if we did something like that, doesn't actually show totally what I want. Not, oops, not a problem with strings. Okay, but I'm going to actually organize my code a little bit here. Public static void show shallow versus deep objects. And then I'm going to actually just pick all this up and put it in there and call that method here. This had to go in there too. Just to separate out our code a little bit, so that when you're running this later, you can sort of pick and choose which of these activities you want to look at. And then we'll just do another one that says that's like strings always string always deep. And we'll go make that method over here. Public static void strings always deep. And we can show that that's here. So this isn't a problem for strings because strings are immutable. So if I make a string hello equals hello, and then I do a string world equals hello like this, and then I change hello to snacks, we're going to see that it only affects hello. So let's just print these. So first we're going to print hello. I'll add hello variable. Oh, variable, right? That's the hello variable. Here we can do the world variable. We're going to change hello to snacks. And then we can do it again here. Change hello. And we can show the hello variable and the world variable again. Okay, so I'm just going to comment out the shallow deep stuff because we're not looking at that for a moment. And instead, we're just going to look at what happens with the strings. So we can see that we have our hello variable and our world variable, and they're equal to each other, which makes sense. Then we change our hello variable to snacks, and then we can see it only affects the hello variable. It didn't affect world. However, had I done this with an array object or a person object, we do know that this would have been a problem. And again, as a reminder, that is because strings are immutable. So that doesn't become a problem. And I have a really fun little example that is coming up shortly. So doing a deep versus a shallow copy, neither is more correct than the other. It just depends on what we're trying to do. So it's just important that we know that we can ask ourselves what we need to do. In our first assignment, we talk about this because you're going to have arrays of objects inside other objects and things like that. And so it'll be really important to know if what you want is a deep or a shallow copy. And when I go over the assignment in a couple of weeks, I'll discuss that as well. Okay, so cloning objects. We can now see exactly what would happen. We're going to just show it in a picture. This is actually what it looks like in a picture. So we have our object 1, we have our object 2. They're in two totally different memory addresses. And if you walked over to those memory addresses, they would be two totally different addresses. But the name would be the same memory address because we didn't do a deep copy of the name. We just said, if we looked at our code again, let me just go back and show you. In here in our clone, this name inside person just passes in the name, and then that just gets set right here. We never said new string name. A reminder that we don't have to do that, but in memory, it is important to understand that because we didn't, we just did it like this, our picture actually looks like this, where both people have the same name variable. But we know that this is okay because it doesn't matter. As soon as one of them change, as soon as one of them change, as soon as we did a change name on Anik 2, this just breaks apart. So this name stays as Anik, and then this name will come over here and be Anik 2. So it's totally fine as soon as we change the name. It's no trouble at all. That includes doing concatenation on the name, a reassignment of the second name variable, anything that we do, as soon as we change it, it automatically makes a new one. And that's why we kind of pretend like strings are like numbers, like primitive values, like Booleans. We just pretend like they're the same because even though it's actually stored like this, as soon as you do any sort of manipulation on a string variable, it acts like an int or a Boolean. It automatically becomes a deep copy. We don't have to do anything fancy to it. Okay. So just a reminder, we talked about this. We had our shallow copy versus our deep copy of how we do arrays, moving every single element over from one to the other is how we do a deep copy. We also have access to this shortcut system.array copy. And there's some information on how you actually use system.array copy is right here. So A1 and A2 are references to arrays that already exist. The 0 here, so this first 0 is about the desired starting position for here. Like what starting element do you want to copy over from A1? And then this one is where do you want to start to copy them over? So then we can use system.array copy to just copy like little chunks of an array if we wanted. But here we of course want to do the whole thing. So we start at 0 in our source and we start at 0 at our destination and we want to copy over all of our elements. This just can be used because of this formula. This can be used to copy over just small segments of arrays or move small segments from one array to another and like shift it in the array as well. So it's just another option. That's all. Okay, so we did that with integer arrays. No problem. We did it. We did our practice with that. But now we have to talk about arrays of objects. Because if we have an array of objects and we want to do a deep copy of it, we can't just do this. We can't just do this. Because rather than A2 at I and A1 at I both just being integers, they are objects. And if these are objects, this is not doing a deep copy of the object. We'd have to clone this and put it in here. Let's see what that looks like, okay? So depending on how deep your arrays of objects go, you actually have to think about what it will mean to clone it. If you have a house, if you have an array of houses, and each house has an array of rooms, where room is an object too, you have to deep copy at each of those layers. So it really helps to draw it out on paper first. So for example, let's just look at that. If I told you we had a house array of houses, so if this was implemented properly, each of these was a house variable. So each one of those is a house object. But houses inside of them, so they have like an address, which maybe is a string, right? So that goes over here somewhere. But it also has an array of rooms, a room array. So that would look something like this. And each of those is a room with a square footage and a number of lights. I don't know, it doesn't matter, right? We can see what's actually happening here is lots of objects stored in objects, which means when we want to do a deep copy this, we have to do a dot clone on this level, and then this dot clone right here has to do a dot clone of this level, and this array has to do a dot clone of this level. So our dot clone method becomes increasingly more complex, where each level ends up calling another object's dot clone. We can see how this starts to be like turtles all the way down a little bit. So let's just look at a picture of this that's drawn a little bit more nicely and cartoony than my ugly red writing. So here we make an array of people. We have two people. We have Farad and Jazz. Both of them are in an array of people. So we make our people array at some memory address. All of this is technically living like this should have actually been living inside this heap as well, but I just didn't have enough space to do that. But in any case, our people has a memory address, and when you follow that address, it takes you over here to the array, where in each of these positions, in people at 0 and people at 1, there's another memory address, and each of those memory addresses take you over here to the people objects where there's a name and an age, and of course the name references a name over here, this one references a name over here, and they each have their age. So as usual, if we wanted to just make another person array and we just said person array others equals people, both are just looking at address 1. So everything affects each other all the same. Here's where it's going to get a little bit tricky. If we do a proper deep copy of the people array to others, but just at that first level, it looks like this. So even just using system.arrayCopy or a loop, all it does is it does a deep copy of the array, but all the information inside is shallow copied. So even though we now have people at 0 that is unique, and a people at 1 that is unique, and an others at 0 that's unique, and an others at 1 that's unique, these memory addresses still reference the same information inside here. So people at 0 references Farad, and others at 0 references the same Farad. So to make two fully independent copies, we actually do have to do this. We have to actually say for every element, do a dot clone. And it's possible, and remember, we wrote the person.clone method. And so it's possible that we would also need to make the dot clone method, not just make a new person, but also do a deep copy, I was putting those words together, of other information inside there, which we'll see in a second. So when we do that, when we actually call dot clone on each of them, we now have two separate people arrays, people and others, and each one has access to people inside, and each of those people are now unique. And, oh, my arrows are wrong here. Let's actually fix that right now, and then I'll re-upload it, because this is going to be actually hugely problematic for those arrows to be incorrect. I tried to make it so that the arrows wouldn't be quite so messy, but of course they have to be, just given their current setup. Okay, let me just present this for just a second here with the proper arrows. That's really, important to me. And I'm gonna, by the time that you'll have seen this, the correct ones will actually be uploaded. So I could have probably just cut all this, but it doesn't matter. It's fine. You'll have actually received this with this picture. So what we can see here is that we have this memory address for people that points to Farad, this one that points to Jazz, and then this one points to this Farad, and this one points to this Jazz. And of course the strings are the same, but it really doesn't matter. As soon as you change like others at 0 dot set name to something else, this will just separate because strings are immutable. Cool. This works exactly the same as objects as a parameter in a method. So there's nothing special about doing this. It's exactly the same as assignment. If the reference is being passed in, it's just passing in the address, and then the address is what gets returned. So then the memory that we changed is affected both in the method and in main. So if we look here, we can see we have like a person me. And I didn't change the names here either. Wow, it's like, come on, Lauren, right? Come on. It's a good thing that all of this is getting re-updated. Me and X. I'm absolutely going to re-update all of these notes. Let me present this again. My sincerest apologies, but the notes you get will be fully correct. So it should be okay. So now we have me and X right here, me and X, and they're the same because right here we say person X equals me. And then when we pass some method me into here, and we call it some method we call person P, look, they're all address 1 because it just passes the address in, which means if we make a change inside this method, it affects this person, which also affects me, which also affects X in this scenario. So understanding that deep and shallow copy, clearly super important. Okay, so there is an opportunity here to do a pause and practice. I have some more information that's coming after, but go ahead and take a pause here. Assuming that a person class has both a copy of like a clone method, and also has a copy constructor, which I'm actually going to just draw out for you in just a minute. There's a bunch of code snippets over these last few slides, and you have to determine if this will be true or if this will be false on your own. So you'll determine if object 1 is equal to object 2. Now, we haven't seen a copy constructor, so that's why I said I just have one more thing I'm going to show you, but we have done the clone. So let's just go ahead and show what a copy constructor would look like. We've seen a clone, right, that looks just like this to do a clone. But if for some reason you wanted to do this a little bit differently, let's just add deep copy with constructor. That's going to be this show. I'll show this method now. Okay, so we're going to do deep copy with constructor. Public static void deep copy with constructor. So if we have a person, we're just going to stick with Anik for right now. Anik 25, and we wanted to make another one, Anik 2. We could do something like this. We call the constructor new person, and we pass in Anik. This is called a copy constructor. So we go over to our person class, and we make a new constructor that takes in a person. And now we can set this.name to p.name and this.age to p.age, and it works exactly like a clone because we're taking this person's information individually and we're putting it into this.age and this.name and this.age, and it will create a new person, Anik 2. And so when we run this and we try to see if these two are equal to each other, they actually won't be. This was a true deep copy. Let's go ahead and look at that. False. They're not equal to each other. It's a true deep copy. Notice also that you can't just do this. This would be a shallow copy still. You have to still copy over each piece of information. You can't just say take this whole instance and set it to the person instance. That's the same as just saying Anik 2 equals Anik. Because this, the keyword this is just the memory address. You have to actually say go to the memory address and fill in the name. Go to the memory address and fill in the age. This.name, this.age. Okay, so you'll see you can go through each of these practices here. I've got a bunch of practice problems. You'll have to code out your own person and clone and copy constructor methods and give them a try and see which ones come out as shallow versus deep copy. Do your best to guess first and then attempt it. But I don't have solutions for this. I don't plan to post any. You can ask in Piazza, or you can just code it up yourself and give it a try and see if your understanding was correct. Cool. So that's it for copying and cloning, and we're going to do some more objects in the other half of these videos.